This is officially part 2 of my Pontiac turbo build. A lot has changed since the last video that you saw in terms of what our game plan is. So if you saw the extras video, I talked about how I tore the original. You saw how I tore the original motor apart, the 455 that was in, actually it's a 400, that was in the car to begin with. The block was cracked. In the extras video, I talked about how I found actually a good friend of mine supplied me with another better casting 400 block to use. Now the idea was we were going to use a Pontiac motor for the Pontiac car, 400 block, and we were going to put a single turbo on it. Another good buddy of mine who's going to be responsible for the majority of the custom fabrication and piping in terms of the turbo and the hot and cold side of the turbo. He's going to be doing a lot of that work, and I'll cover that when we get there. That's a little bit further down the road. He came over, we were sitting here staring into the engine compartment of this car for probably a solid 20 minutes, just sitting here thinking, how in the world are we going to make this work? The biggest issue with, and I can show you here in a minute with Pontiac motors, in terms of fitment, and when I say fitment, I mean it's already hard enough to put headers on a naturally aspirated Pontiac motor in an A-body car. If any Pontiac guy is watching, they know exactly what the hell I'm talking about. The reason is because the exhaust ports, the way they're cast in the heads, it pretty much points the exhaust runner right into the frame rail, and it leaves you almost no room to have a flange and a pipe to intelligently route anywhere. So there are some companies that make headers, none of them fit. They might claim they fit, they don't. So to make this even more complicated and do the opposite and run the headers forward around the front of the engine to a turbo is turning this into just an absolute nightmare. And we got to the point where we're thinking, okay, I can't use the motor that was in the car because the block was cracked. The engine block that I got from a good buddy of mine was also cracked, and it's going to need a sleeve put in to fix it, which I plan on doing. But is it really worth all of that effort to put a factory cast iron block into this car that it's going to be a little, even a good casting Pontiac block, to ask for 800 horsepower, it's debatable, but from what I've read, is a lot to ask for. Let's just bite the bullet and get an aftermarket Pontiac block, a good one from Butler or somebody else. You can't get a good cast iron aftermarket Pontiac block for, by the time you pay for tax and shipping, you're paying over $4,000 for just a block. And I build engines for a living. I can get an engine of a Chevrolet engine block of equal quality for half of that. So it just seemed like the harder we tried to make the Pontiac motor work in terms of budget and just getting it to fit and work, the more we tried to do it on paper, the less realistic it became. So in the extras video, I mentioned that I had developed a new plan, and here it is. So this is the car. I don't know if in the previous video, there's not much to see here because there's nothing in here anymore. And there's going to be a lot of moving around going on here. The battery is going to have to be relocated to the trunk for what I'm going to do. I'll explain that to you very soon. And the electronic vacuum pump, all that needs to be moved. Fuel system's gonna all have to be changed. But to free up some space, we're going to put a, don't freak out, a small block Chevrolet in our 66 Pontiac GTO. What do you think, Bob?
I think it's a great idea. What the fuck are you talking about?
A little persuasion from Bob made me realize that my original plan with this Pontiac is just nonsense. Not that it's impossible, but dollars for dollar, and for the amount of time and effort it's going to take, does it really make that much sense to have, at the end of the day, a motor that's going to produce probably more horsepower than the engine block can handle anyway? Right. Right. So don't freak out, but we're putting a small block Chevrolet into our 1966 Pontiac GTO. But not just a regular small block Chevrolet. This one is going to be a little bit different. And no, we're not LS swapping it, but we sort of are. So this is what we got. This here is a World Products Motown II LS block. It will look more familiar if I flip it upside down. So this is a high quality cast iron, just high quality, better geometry, very strong small block Chevy, 4-bolt main, splayed on the center 3, and it's even 4 bolts on number 1 and 5. It's all good stuff. Basically, this is a very, very strong block that is stronger than what I need for the power levels that I'm looking to make. So from this angle, this looks just like a small block Chevy to you, other than the fact that it has some extra bolt bosses for if you wanted to put this motor into an LS powered car, like a later model Corvette or Camaro or something, you can actually bolt LS engine mounts directly to this block and put it right in that car if you wanted to. Now, this car is already set up. It's a GMA body. You could put a small block Chevy in this thing, no problem at all. It'll bolt right in. So this is perfect, right? Best of both worlds. While we're looking at the underneath of this thing, there are some differences. Freeze-out plugs are in a different spot, and there's also a tapped hole here. So you could go ahead and plug this hole if you wanted to and run a traditional style cooling system, but I'm going to utilize these holes and do something a little bit more fancy. I'll get into that in a later video. Basically, we'll introduce the water into the center of each side, that's on both sides of the block, of the engine block for better cooling, so that the water temperature throughout the entire motor is closer to the same temperature, rather than having, in most cases, the colder water is in the front of the motor and the hotter water is in the rear of the motor. By the way, this is standard small block Chevy 350 main size, and the cam tunnel is raised so that if you wanted to put a 4-inch crank in this, you don't have to do any, the clearancing's already done, and you don't have to deal with any kind of small base circle camshaft nonsense. It'll clear the connecting rods no problem. The biggest difference between this and a regular traditional small block Chevrolet is the fact that this is going to look a lot different to you if you are familiar with small block Chevrolets. This accepts LS style cylinder heads, LS1 through 7. I'm going to be running LS3 style, LS3 heads on this thing. It comes with this adapter plate. We refer to it as the China rail. On a regular small block Chevrolet is lower than it is on an LS motor, so this adapter plate is here to compensate for that. And there's also 5 very small head bolt holes for the LS cylinder heads that need to go into here as well. So this actually bolts onto the top of the block. There's a plate that bolts on top of this that seals this off. But what's nice about this, that a luxury that you don't get with the LS motors, is you can remove this plate and have access to the lifter valley. Whereas with LS motors, you actually have to take the cylinder heads off the block to have access to the lifters. I think that's pretty neat. Speaking of the lifters, this block has bushed, it has lifter bushings. They're not just bored into the block, they're actual bronze lifter bushings. They're 904, they're to accept 904 lifters, which are larger. The typical size is a 42. Larger lifter diameter is going to be more robust. A larger diameter axle for the roll, it's going to be roller lifter obviously. Larger diameter axle for the the roller and a larger roller. So those are good things in terms of durability. So basically, what is this? This is 4-inch 125 bore, and I so badly wanted to put a 4-inch crankshaft in this thing and make it a 427. That's how the math would work out. I would have loved to have had a 427 small block with a couple twins on it. Unfortunately, the turbos that I have, which we'll get to here soon, aren't large enough for that amount of cubic inch. And the power levels I want to reach, I don't need that much cubic inch anyway. So we're putting a 3 3/4 inch crankshaft in this block with a 6 1/8 inch long rod, which is going to come out to 401 cubic inches. What you end up with is small block Chevy bottom end, very strong design. You don't have the issue like you do with the LS motors, because LS blocks are Y blocks and they're 6 bolts. LS motors typically have a windage issue. They don't vent very well between banks. You don't have that problem with the small block Chevrolet. So that problem has been removed. Other problem is I don't have to mess around with any kind of special engine mounts, any kind of modifications to the car. I don't have to have any kind of special oil pan. I have traditional small block Chevrolet stuff. I bolt it right in the car. That's it, we're done. Everything on top is LS stuff. LS 3 heads. Probably going, I don't have it yet, but probably going to utilize a Edelbrock ProFlow intake manifold and a Holley HP fuel injection system, the whole deal. This is the bridge between the best of both worlds, in my opinion. You get the small block the greatness of the small block Chevrolet. You get a lot of cubic inches, and you are able to utilize really good cylinder heads without spending tons of money on cylinder heads. One could easily build a small block Chevrolet with really good CNC ported cylinder heads, and it probably work just as well. But rather than spending $2,000 on cylinder heads, you could spend $200 and pick up a set off of an old pickup truck at a junkyard. Not that this is a budget-driven build, but I want this to be fuel injected, and it just seems like it would. The whole thing's going to work very well with the LS stuff on top of the small block Chevrolet. And at the end of the day, it's technically going to be a larger engine that came in it from the factory. 66 GTOs came with a 389 tri-power or 4-barrel big block. Well, a lot of refer to it as a big block. So this is a small block that's actually going to be larger in displacement than the factory engine was that came in this car. On top of all this, this is going to leave us a lot more room in the engine compartment for piping for our hot and cold side of the turbo setup. And with all this extra space, instead of using one big turbo, we're going to use two 66mm BorgWarner S366 turbos. So it'll even look cool. So a little bit of symmetry in the engine compartment, I don't think it's going to be a bad thing. So while we're talking engine blocks, let's quickly move back to the block that came out of this car. In part one, I explained how it was cracked, and it is. And because of that, a dowel had fallen out, and if you saw part one, you know all about this already. But I didn't show you the block. All right, so this is our 1975 casting 400 Pontiac block that came out of this car. They're junk. Don't ever use them. Seriously, they're horrible. I should know. So, like I explained in part one, just for fun, wash the block. I just wanted to make sure there wasn't anything super crazy going on with this thing, and there was. And I mentioned how there was a dowel that fell out. These dowels here locate the main caps, and the bolts hold them in place. Well, the dowels keep them in place, and the bolts provide the clamp force to put the right amount of pressure on the bearings so that they're round and it holds the crankshaft correctly. Without these dowels, there really isn't anything holding the main cap in place. In other words, even if the cap is tight, it can still move around because there is no physical object to locate it, to keep it from moving. So the block cracked right here, right on the dowel. And you can see a difference in coloration. It's probably hard to see on the camera, but believe me, because I'm sitting here staring at it right now, crack right here, right across the very center of the dowel. There's so little material here between the webs that this is actually a through hole. The hole goes all the way through to the other side, so in order for the dowel to have come out, it would have had to go this way, which would be coming up. And it could do that because there's no material back here to keep it in place, because these later casting blocks are just so much thinner than the earlier ones. But anyway, back to the crack. The crack starts here and it goes right across the main web here, and it goes straight into the cam tunnel. That's very, very, very bad. It's a good thing that we tore this thing apart. I would have been very bummed out if I would have spent a lot of money on parts and had the block break into 2 pieces because of something like this. So anyway, that's why we're not using this block. So on top of all these reasons to not use a Pontiac motor in this car, when I finally got the better block, upon further inspection, that one was cracked also, in a totally different spot. It was cracked at the bottom of, I think, number 4, I don't remember. One of the cylinder walls at the very bottom, it was cracked, and the crack goes straight up the cylinder wall. At this point, I'm over the Pontiac thing. I'm so frustrated with dealing with this kind of stuff. The second block in a row that's cracked, and I'm going to be pushing boosts through these things. I'm not screwing around anymore. We scrapped the Pontiac engine idea right then and there. All right, so what are we putting inside of our new Motown II LS block? I mentioned we're not going to do a 4-inch crank. We're going to do a 3 3/4 inch stroke crank, and this is it. This is a Cali's crankshaft. Obviously it's forged, it's not balanced. I'm going to be balancing it. Like I mentioned before, we could have easily fit a 4-inch stroke crankshaft in that block without having any issues, but it would have made the engine too large for the size of the turbos that I'm going to be using. So at 400, it's going to technically be 401 cubic inches. That's going to be more than enough cubic inch, actually perfect for the size of the turbos to make this both a streetable car and to make the power levels that I'm looking for. Really, for the parts I have, I'm not asking for much, I don't think. What are we connecting to the crankshaft? A set of 6-inch 125. When we talk about rod length, we talk about the center of what we refer to as the big end, which is the side that bolts to the rod throws with the rod bearing, and the pin end, which is the side that the piston goes on. The center of this hole and the center of that hole, that's your rod length. This is a longer rod. It's better to have a longer rod. Usually you want as long of a rod as you can possibly fit. So I could have done a 6-inch rod, but I wanted to make it 6 1/8 because I just like using longer connecting rods. This should be more than enough. This is a good forged piece. It's not the best that Cali's offers, but I do have the ARP 2000 volt upgrade. I've built many motors that have made well over 1,000 horsepower, and we've never ever had any problems with this line of connecting rod. So this is what I will be using. Connected to the connecting rods, obviously we need pistons. So this is a custom Wiseco piston. The reason it's custom is because this is an LS piston, because I'm using LS heads. The valve reliefs and the shape of the piston are not the same between an LS and a small block Chevrolet. So I'm using LS pistons with traditional small block Chevrolet parts. With that said, the factory stroke of like your typical 6-liter and many others, LS motor is 3-inch 622. That's the factory stroke. If somebody were to stroke an LS motor, usually they jump straight from that to 4-inch. So if I were using a 4-inch stroke crank, all I would need to do is order a LS piston for a 4-inch stroke LS crank. Unfortunately, since I'm using a 3 3/4 inch crank, nobody makes a 3 3/4 inch stroke crankshaft for an LS motor, which means nobody makes a piston for a 3 3/4 inch stroke crankshaft for an LS motor. I got these pistons from John Booley in Kentucky, Little John Motorsports. He's an absolutely amazing person, very, very smart, and he was a major help. We modified a LS piston for a 4-inch stroke, and we moved the pin bore down to compensate for the lesser amount of stroke that I will be using. This would be normal for a small block Chevrolet. A lot of people will put a 3 3/4 inch stroke in a small block Chevrolet. That's no big deal. LS motors, not so much. If you're ordering a higher quality piston, oftentimes you have the option for a pin upgrade. Now, you saw me remove this from the piston. That's how it was packaged. The pistons are packaged individually with their own set of rings and wrist pins. I've got one open here. This is the wrist pin that comes with the piston package. I opted for the higher quality, larger wall thickness wrist pin. Visually, you'll notice that the hole that goes through the center of the pin I'm going to be using is smaller than this one, and that's because the wall thickness is thicker with this. This pin's going to be a little bit heavier than this one. That's just the way it has to be. I'm giving up the lightness for the strength because I think that the strength of the pin is more important. It won't hurt performance at all. It'll make it more robust package. And of course, when you're dealing with higher quality stuff, it's just so nice when everything fits. I mean, the wrist pin fits in the rod, and these are from 2 different manufacturers. It's just buttery smooth. You don't get this with cheaper stuff. So you get what you pay for in this world when it comes to motor building. Wiseco pistons use their triple spiral lock locks. I absolutely hate them. These things suck. I prefer the round wire locks. I can get into that in a different video. I don't have an option with these. This is the way Wiseco likes to do it, so that's just what I gotta do. Talking about pin location in the piston, if you notice here, the actual pin bore in the piston is up so high that it actually bisects the oil ring groove. Now, because of that, in this portion of the piston where the pin is, there's no support there for the oil ring. And to fix that problem, you have what is called an oil ring support rail, which is this. This is nothing more than just a hard, very sturdy ring that fits in the bottom of this groove, like so. It goes on just like a regular piston ring, but once installed, it sits at the bottom of this ring groove, and now it has bridged the gap here, so the oil ring now has support. And this support rail, the radial depth of it is less than the actual size of the piston, so it has absolutely no effect on the way the rings behave or how it acts. It doesn't even come close to the cylinder wall. It is there just to support the oil ring, but it is absolutely 100% necessary. Not using this or forgetting to put it in is going to cause you just an enormous amount of problems. So that's what that's for. Moving on, back to my friend John Booley in Kentucky at Little John Motorsports. He spec'd out a camshaft for me. This is actually quite an interesting camshaft. It might just look like any normal camshaft to you, but it is most certainly not. This is an LS camshaft, okay? It has the 3-bolt flange on the front. It has The mains are designed for 55mm cam bore, and the location of the cam lobes is for an LS motor firing order. Because we'll be using LS heads, this is what we have to use. But we're using a small block Chevrolet block. You can't just slide an LS camshaft and a small block Chevrolet block. So this is actually a pretty tricky camshaft. This has not only, won't be using it, but it does have an eccentric on it to run a mechanical fuel pump like a traditional small block Chevrolet does. You'll never see one of these on an LS camshaft. Another thing you'll never see on an LS camshaft is an oil pump drive gear. The oil pumps are driven on LS motors off the nose of the crankshaft up here. On small block Chevrolets, they're driven off of a gear on the back of their camshaft. The same gear also drives the, well, not the same, well, the gear drives the oil pump, and the oil pump drives the distributor. If I wanted to use a traditional style distributor in that engine block, I failed to mention this earlier, you can use a regular distributor in that block if you want to. I won't be doing that. It'll be coil unplugged, electronic fuel injected. And instead, they make a part that basically looks like the bottom half of a distributor, but at the top, it's just like a circle with a wire coming out of it, and it's nothing more than just a rotary in there that's a cam position sensor that will plug into the computer to tell it what the cam timing is. There's only two ways that you can get this cam core, and when I say cam core, I mean this camshaft comes as a steel core, and then the lobes are ground after the fact. I asked Comp Cams if they could make this camshaft. They said they would do it, but the camshaft alone would cost $1,400 for just the stick, because of all the modifications they have to do to it, putting this gear on it, these size mains, everything to make it work in that block. So this cam core comes from Callie's. Callie's makes this cam core, and you can either get it directly from Callie's or you can get it from Urson Cams. I went to Urson Cams and they ground it. But I had John Booley at Little John Motorsports spec the cam. So basically, I went to Urson Cams and said, I need a cam core for a Motown II LS engine block, but I want you to grind it to these specs. I told them exactly what I wanted, and they said, okay, they did it. It arrived a few days later. This is a pretty tricky piece. And I'm sure that I did exactly what John wanted in terms of the profile of the cam lobes. It ought to work just absolutely killer. That guy is when it comes to LS camshafts, that guy knows what the hell he's talking about. And I have plenty of cam guys that are very good that I trust, that I really trust a lot, and he's good. Lastly, I got a timing set. Now, I mentioned earlier that this block has a raised cam tunnel. So a regular traditional small block Chevy timing set isn't going to work because the cam chain isn't going to be long enough. So this is a cam set from PBM made for that block. And this is pretty cool. They have a few different options. You don't have to get one this tricky, but I wanted it just because I think it's really cool. You have one gear on the to go on the nose of the crankshaft, and then it's an actual adjustable cam gear here. You probably can't see it from where you're at, but these bolts here, you loosen these up. This is actually two pieces. You have a tool here that slides in these, and you can turn this, and you can basically fine-tune this and degree the camshaft into exactly where you want it to be. This is pretty cool, and it was pretty reasonably priced for how nice of a piece this is. It has a roller bearing on the back. This is just a nice, really nice piece, I think. So I'm pretty excited about that, and it's a good thing that PBM offers this, or else this entire package wouldn't be possible. I got a set of used LS3 cylinder heads off of a friend of mine. I've known him since the first day of college. So these are used LS 3-cylinder heads off of a Pontiac G8 GXP, and this one is used in decent condition. It's complete. I'm going to be replacing all the valves and springs and everything anyway, but I just needed a good casting head. This is a good casting head. I got a real killer deal on these things, and you're about to see why. The second head is not in such good condition. So the tulip of one of the intake valves broke off, as you can see, and it got jammed in into the intake runner sideways. Not supposed to look like that. And debris from that and the piston has obviously gone back through the intake manifold and polluted all the other cylinders, and there's a chunk of piston holding this valve open here. So this head's hurt pretty bad. But I work in a machine shop. I'm a machinist. This is what I do for a living. I can fix this head. So I got a spoken deal on these heads. I just need to put a little bit of work into these things to make them functional. So there'll be a separate video of me fixing these heads, and I think it'll be pretty neat because this head to most people would look like it's ready for the dumpster, but when I'm done with it, it'll look like a brand new cylinder head. LS 3-cylinder heads is what I'm running. Nothing tricky, no CNC porting, nothing like that. This will be a honest-to-God street car, and it will run on pump gas. I always say peak numbers don't matter. They don't, but if I can make 600 to 700 to the rear wheels on pump gas, I'd be happy with that. I also would like to do a race gas tune, and I think we could probably hit 1,000 on race fuel. So that's what I'm looking for, but pretty much wherever it ends up is, I'll be happy. It'll be more than enough for that car. This is not going to be a race car. This is a street car. It's going to have way more power than it needs to have, and it's not going to be fast. It's a stick car. It's not set up for drag race. It's not set up for any real kind of racing at all. I mean, it does have a coilover suspension. It has really good parts in it. But this is just going to be, it's going to sound good and make fun turbo noises, and it's going to melt the tires off, and it ought to be fast. And if I want to roll race with it, it'd probably be good at doing that. So, lastly, to get you guys 100% up to date, these are. This is all the parts I've acquired so far. So these are my turbos. These are Borg-Warner S366 turbos. They're 66 millimeter, and they're brand new. I bought them from a shop up in the Akron area of Ohio. They were using them for a car that they were building, and then the owner of the car decided that they wanted to use a different turbo setup. So basically they took these out of the box and they couldn't use them, so I bought them, and they've never been used or mounted. So they're brand new turbos. I got a pretty good deal on them, so I'm pretty happy about that. That's what we're using, 2 of these guys. And honestly, from the very beginning, I always thought it'd be very cool to do a twin turbo setup in this car. I think it just 1 turbo per side. It just looked cool, you know. It wasn't going to be possible using the Pontiac motor, but it is going to be possible using the small block because we're going to have so much more room now. I'm pretty excited about this. I think this build's going to be pretty interesting, and I don't think that there's a whole lot of people out there using this small block Chevy LS hybrid engine setup that I know of, at least. To the average person, it'll probably just look like an LS motor sitting in the car. I've got a few more parts to order. The last trick is going to be lifters. Like I mentioned earlier, LS motors use a 842 lifter, and I got this engine block with 904 lifter bushings. I didn't realize at the time that that was going to create such an issue. If I'd known that, then I would have just gotten the block with 842 lifter bores. I thought bigger was better, and I thought I was being proactive, and I thought that'd be a smart idea. That it's become a problem because there's very few companies out there that actually make LS lifters in a 904, and unfortunately they're really expensive, so, which is okay. I'm probably just going to have to pony up and buy expensive lifters, and that's fine. Lifters are very important. I'll probably end up going with like a Morel tie bar style, Morel or Iski, something like that, in a 904. And the rest of the parts I'm going to get from John Booley again at Little John Motorsports, just because he was so helpful. I know I keep going on about him, but I mean, he was really, every single time I called him, he picked up the phone right away. He remembered my name. I mean, he remembered the build. He's just been, out of everyone I've dealt with in terms of getting parts, he's just been just such a help, because we've never built a motor like this before. We've never built a LS small Chevy hybrid like this. So this is, I'm getting into, you know, I'm not very familiar with some of this stuff, and he's been able to help me out a lot. He sells everything you need. I'll be getting the intake manifold, fuel rails. I won't be able to get the lifters from him, but I've got vendors to get the lifters from. And then just some little things like timing cover. I'll probably go with a billet timing cover, and I'll need a higher capacity oil pan. I'll have to weld in some fittings for oil return for the turbos. Just some little things like that. Valve covers, coil packs. And then to top it off, the Holley EFI fuel injection system. That's what I got left to order. Right now, I can start machining on the block, decking the block, finish honing it to size, balance the crankshaft, the rotating assembly. I can put the short block together. I can actually put the camshaft in it, timing set. There's a lot that I can do, and I need to start get moving on that quickly, because we're going on the Hot Rod Power Tour in June, like the second week of June. It's almost April 1st. And that's what the car looks like right now. This is what the motor looks like. So I got to hustle. So, and there's a lot more things we got to do with the car. I got to modify the fuel system to support all this. I'm putting a new transmission in the car, a TKO 600 5-speed. I still need a bell housing. I need a really strong twin disc hydraulic clutch. I got to mount the master cylinder for the clutch and the lines for that. There's a lot of work to be done here. So we're really going to be pushing it to make it, but the goal is to get this thing on the Hot Rod Power Tour second week of June with a 400-inch small block in it with 2 turbos, making 1,000 horsepower. So that's where we're at now. Stay tuned. Next, we'll probably be talking about machining and balancing and doing a short block. So, thanks for watching. I hope you guys enjoyed this. I know it's been a while since I posted an update on this car, but I've just been so busy doing other stuff. Customers come first, playtime second. So, anyway, thanks a lot. If you like this, subscribe to the channel. There's going to be a lot of stuff like this. Not just my build, not this car. Lots of general machining and engine building and engine dynoing and testing and all kinds of stuff like that. So if you're a motorhead like myself, this is the channel for you. So thanks a lot. Take care.